So one of the really big challenges that the power grid is going to face in the future is this concept of what we call wide area extreme events. So, two notable examples of that would be Winter Storm Uri, Winter Storm Elliott, or the Pacific Northwest heat wave that happened in 2021. And the reason why these events are so bad is not necessarily because the temperatures are really low or really high, but it's because they're really low or really high over a very wide area. And so what happened in Winter Storm Uri was they ran out of power, right? It was really cold in ERCOT, MISO, and PJM all at the same time. The challenge that climate scientists and grid planners have is that forecasting joint tail risk is very challenging to do and has not yet been figured out. So forecasting the likelihood of these wide area extremes, which is necessary for substantiating investments, has not yet been figured out. And so we recently won a grant from the DOE under the Grid Modernization Initiative in collaboration with Argonne National Labs, NREL, Lawrence Berkeley National Labs, Wisconsin University, Rutgers, Jupiter Intelligence, Ameren, and Constellation, and then who I work for, Baringa Partners. So quite the consortium to actually solve this exact challenge. So the project is called Cascade for cascading events, and we're going to forecast the likelihood of these joint tail risk for these wide area extremes, and then understand what their impact is to the market. And the idea is that once you forecast the likelihood of the extremes, then that gives you a baseline of risk that you can substantiate investments against to mitigate these wide area extremes. So in the case of Uri, maybe it would be building additional transmission, maybe it would be adding additional storage.